We've looked at a lot of different series, and now we're going to concentrate on the idea of using power series as a tool to approximate functions with polynomials, or functions of polynomials. Where we're actually heading is that we can approximate transcendental functions using a polynomial, which is a very powerful thing to actually do. So looking ahead at where we're going here, we want to be able to, learning objectives, we want to be able to recognize what a power series is. We want to estimate the value of a function based on what's known as a Taylor polynomial, which is really a form of a power series. And we want to calculate the maximum error in an estimated, in a function estimated based on a Taylor polynomial. I should have the word function in here. Okay, so let's talk about just exactly what is a power series. You've seen a power series, although we haven't actually called it that yet. A power series is an infinite series that has this form. The infinite sum, k equals 0 to infinity, of ck times x to the k, where ck is some constant. So this is going to be equal to c0 plus c1 x to the first plus c2 x squared plus on out to ck x to the k and so forth on out to infinity. Now, very commonly we talk about the idea of a power series being centered at A, in which case the power series then has the form, the sum k equals 0 to infinity of ck, some constant, times x minus a to the k. Being centered at a means this right here, x minus a. So when x is equal to a, this whole thing equals 0. And of course, that expands to be c0. Now, x minus a to the 0 is 1, so I'm not going to bother writing it. And that is a c. It kind of looks like an e, sorry. Plus c1 times x minus a to the first plus c2 times x minus a squared plus yada, yada, yada on out. So this power series up here, this is actually centered at 0. Because see, this x right here is actually x minus 0 to the k. So this is centered at 0, and this down here is centered at a. So notice that a power series is actually just a polynomial of increasing degree. See, this is just a polynomial. And it is by increasing degree. So like the 0th degree, that is nothing more than c0, c0, where I started at. The first degree, that's c0 plus c1 times x minus a to the first. See, this is a first degree polynomial. The second degree is going to be c0 plus c1 times x minus a to the first plus c2 times x minus a squared. And this keeps right on going down to the nth degree, which will give you c0 plus c1 x minus a to the first plus c2 x minus a squared plus out to however far n is, cn x minus a to the nth. Which, of course, I could write all of this as the sum k equals 0 to n, because n is where I'm stopping, of ck times x minus a to the k. Now, we can use this to actually approximate very complex functions with a polynomial based on a power series. In a minute, I'm going to do some examples here involving sine x and e to the x and square root of x, all based on something that looks like this. That's an extremely powerful idea.